Hello, everyone. Thank you for joining. My name is Chris Adams. I'm the online community manager for ModernAnalyst.com, the premier community for business analysts. I'd like to welcome you today to today's webinar entitled Software Requirements and Organizational Culture, 10 Lessons Learned. Today's featured speaker is Carl Wiegers, Principal Consultant. The webinar will last approximately 60 minutes, including the Q&A at the end. So please be sure to submit your questions in advance using the questions feature of the GoToWebinar software. I'd like to say thank you to IREB, International Requirements Engineering Board, for sponsoring this event. There is a handout from IREB that is available for download in the handout section. And at this time, I'll go ahead and turn it over to Stefan Sturm to say a few words before we get started.
Yeah, Chris, thanks for the introduction. Hello, everybody. I'm Stefan Sturm. I'm the Managing Director of the IREB, the International Requirements Engineering Board. Just want to give you a few informations about IREB before I hand over to Carl Wiegers for the webinar. So the IREB is a panel of renowned experts in RE who share their expertise in order to provide an enduring education concept, the CPRE, the Certified Professional for Requirements Engineering. And the three-tier certification scheme consists of a foundation level, which gives you the basics, no prerequisites if you want to go for that one, several advanced level modules where you specialize in certain areas of requirements engineering, and on top of that there will be the expert level, which will be launched in the next 2 months, and you can go for the exams from January 2018. And especially the agile area we are targeting with a primer, giving an introduction as well, no prerequisites here, and the advanced level will be out before the end of 2017. Okay, that's all from my side, and I hope you will get valuable information now from Carl Wiegers. Please, Carl, the stage is yours.
Thank you, Stefan, and thanks to IREB for sponsoring this webinar. Welcome, everybody. Greetings from rainy Portland, Oregon. Looks like fall is here. Well, thank you for joining us today. This slide gives you some contact information for me if you want to get in touch, and also shows some of the books I've written. And I'm especially excited about the one on the right. The Reconstruction is my first novel. It was just published a few weeks ago. It's a mystery about a forensic sculptor who completes a facial reconstruction on some unidentified human remains and is shocked to discover that she has a close personal connection to the victim. And she's then driven to identify the victim, determine what their connection is, and find justice for her death. Doesn't that sound fascinating? It was a lot more fun to write this novel than any of my software books, but those are useful too. You might also want to visit the goodies page at my website. I've got a second line from the bottom there has a URL where there's a lot of downloadable process goodies, and those are collected in something cleverly called the Process Impact Goodies Collection. And if you are interested in that, there's a discount code there that you can use. GOOD17 will get you $20 off that goodies collection. So you might want to check that out and see some of the templates and things that we'll be talking about in today's webinar. So the ideas that I'm going to share with you today are based on 2 of my books, not the Reconstruction, but the other books. My first book, published back in 1996, was called Creating a Software Engineering Culture, and it was based largely on my experiences working in and managing some small software groups when I worked at Kodak. I came to appreciate how important the culture of an organization is when it comes to how well people can collaborate to build the right products in an effective and efficient way. So I will share with you as we go along some of the cultural principles that my group thought were important and how they helped us do a better job and how that ties into requirements. Well, I think the requirements practices in particular have a strong association with an organization's culture because they are not strictly technical. Requirements are much more related to human interactions and communication than to the specifics of the computing technologies that are being used. So many of the specific principles and practices that I plan to discuss today come from my recent book with Joy Beatty called Software Requirements 3rd Edition. So the first lesson that I'd like to share with you is the idea that every software organization should determine its underlying cultural principles. And that gets to the idea of what I mean by a software engineering culture. This is an idea that I thought about a lot, and I think it's pretty important. So to me, a software engineering culture is a set of beliefs and behaviors and technical practices that collectively define an environment in which all of the team members are committed to building high-quality software products through the application of effective and appropriate software processes. Now, culture is kind of a vague thing, but in other words, this is a list of the values and the practices that the members of an organization largely share and agree are important to its success and the ways people will work together toward that success. As an example, teams, and I'm sure many of you fit in this category, teams that have adopted agile practices have certainly agreed upon certain principles and techniques that they believe will help them be more effective compared to some other set of principles and practices. And that has a very strong way of defining their software engineering culture. So Agile in itself is probably at least as much about culture and behaviors and values as it is about practices. Now, my experience has been that many organizations have not explicitly talked about these things, about what's important to them and their priorities and how they do their work. But if a shared culture like this is going to be meaningful, then people do have to talk about it so that they can agree on what are our drivers, what are our values and principles. And they need to understand that this requires several levels of commitment by the members of the organization. It requires a commitment by each of the technical practitioners there to apply sound software engineering practices. Now, we can have raging debates over what constitutes sound software engineering practices, but there's a pretty extensive body of knowledge here that I'm sure you're all familiar with that helps us understand better ways of building software versus less good ways of building software. Well, let's try to do the better ones, and let's continually learn how to do that better. It requires a commitment by managers at all levels to create and provide and sustain a quality-driven environment so that we understand that that's what's important around here. And it requires commitments by everyone to continuously learn and continuously improve the way they work. I don't believe anybody can say, I am building software today as well as software could ever be built. And if you can't say that, you should always be spending some of your time, both as individuals and as organizations, to learn more and to improve the ways you work. That, I think, is just being a professional. So here are some of the principles that my group, that really was kind of the foundation of what led to the creating a software engineering culture book, some of the cultural principles that we really agreed were important to us. And because everyone in this little organization thought these things were important, we took actions on our projects that were consistent with them, because we were committed to the idea that they would give us better results than we used to get before and better results than we might get otherwise if people just worked in whatever random ways they thought were best. So one of the principles is that you should never let your boss or your customer talk you into doing a bad job. Now, sometimes people who don't really understand as much as maybe they think they do about software will try to suggest approaches that we know are not a very good idea. And I saw a great example of this once. There was some project that was late, of course, and somehow one of the managers involved there, who was not a software guy, got the idea that unit testing was slowing things down. And so he decreed, okay, nobody does unit testing anymore. Well, I think that's a pretty bad idea. And if my boss tried to tell me, okay, I don't want you to do unit testing anymore, that stuff's just a time waster, I would, first of all, try to explain to him why, no, that's not the case. Unit testing is actually a high value added activity. And if for some reason that message didn't get across and I was getting pressure to not do something that I thought was a good thing to do, I would just do it. Or if somebody tried to talk me into doing something that I thought was a bad thing to do, I would not do it. And you always have to decide how far are you willing to push this. But I think each of us needs to think about whether or not you agree with these kinds of principles. I'm not saying that these cultural principles that our group shared are the right ones for you, but I do hope that you will think about which of these might apply to you, and if there are others that apply, then write those down too. I believe quality is your top priority and that you get long-term productivity as a natural benefit of high quality by avoiding doing a lot of excessive rework for things that were broken from the get-go. So I focus on quality, and productivity comes out of that. I believe you should strive to have a peer rather than a customer find a defect. We make mistakes. It's unavoidable. And if you want to know what review is like, write a book sometime and get some input from people. They'll tell you all sorts of stuff. But I would much rather have one of my reviewers, one of my colleagues, one of my friends tell me I did something wrong than have the customer find it, or have the person who's writing a review of my book online find it. I don't want those people to find problems. I think ongoing education is every team member's responsibility. As I mentioned, we should all be learning how to do a better job pretty much all the time, a little bit of our effort. I think people need to feel that the work they do is appreciated, and this is very much a cultural kind of thing. In your organization, is there any kind of a reward or recognition program? If people do something particularly well, or if they make some particularly special contribution or help somebody else out, do they get recognized for that in any way? I think they should. And so we instituted a little simple recognition program when I took over management of our group, and I think it was quite successful. Oops, sorry, that didn't format very well, did it? Continual improvement of your software development process is both possible and essential. We can always be finding better ways to work, so let's look for them. One of the keys to software quality, I believe, is to iterate on all the development steps except coding. It's more expensive to iterate on code than it is to iterate on a design. And it's more expensive to iterate on designs than it is to iterate on requirements and concepts. So let's iterate a lot on those cheaper activities where we get a lot of benefit from thinking about different options and exploring possibilities and trying things and then refining. And let's not write the code a whole lot of times because that's more expensive. I don't like throwing away stuff that I've already finished. I believe that if you measure what you do, you can learn to do it better. And if you believe this also, then you'll have some kinds of software metrics activities going on in your organization. And we started a number of metrics programs in our group that I think provided us with a lot of valuable information and insight into how we work. But remember that even if you want to change things, you can't change everything at once. People can only absorb change at a certain pace. So don't try to fix everything that might be broken at once. Don't try to adopt a whole raft of new approaches at once because you simply can't. So like I said, I'm not saying all these principles will be exactly right for you, but I strongly encourage you to think of these, which of these would pertain to your own team's culture, and ask yourself, what other principles do you think help define your culture? Then ask yourself, do you think those principles are widely understood, shared, and applied consistently by your team members? This thought process is really a matter of getting to understand the values and practices that characterize your team's culture. All right, so the second lesson that I've learned is that management at all levels plays a really major role in steering and shaping the culture of the organization, and that can be a good thing or it can be a less good thing. Now, really what we want to focus on is not what people say, but on what they do. Anytime you see a disconnect between what managers claim to be as important and what their actual behaviors are under certain circumstances, then you don't really know what their priorities are. So congruence and consistency between statements and actions is really important if the managers are to have credibility. For instance, if your managers claim quality is a top priority, but then they rush a product to market before it's really ready to release just because the release date has arrived, then you know quality is less important to them than meeting schedule. Ideally, we'll do both, but sometimes we have to make trade-off decisions. So some things that I've found helpful to get my head around these behaviors is to look at a set of culture builders and culture killers. Culture builders are actions that someone, usually a manager, takes that help establish and reinforce a healthy software engineering culture. By contrast, culture killers are actions that, again, someone, usually a manager, takes that, in my opinion, undermine a healthy culture. And I've marked these culture killers with this subtle skull and crossbone symbol to suggest that they are not good things to do. Watch out for those. So my book, Creating a Software Engineering Culture, presents dozens of culture builders and culture killers, many of which are things that I've actually seen people do, both for good and for less good. Let me show you a few examples here. Here's an example of a culture builder that we found. We have some projects that we worked on occasionally when I was writing software for internal use in the Kodak research labs. And we had taken an approach around requirements of having product champions serve as key user representatives on our projects. And we really wanted people from the user community to fill this role to really help us focus the project on meeting the needs of the user community. So we needed these product champions. And every once in a while, we'd have a project we were asked to work on, and we could not find anyone who was willing to be a product champion. No one cared enough about the project. No one had enough of a mental image or vision of the project we were trying to work on to really want to help steer us. And in that case, I think you should cancel the project, because you're going to fumble around, you're going to do your best, but you're not going to probably do a very good job of meeting customer needs. So why spend a lot of resources and money on something like that if you maybe have other projects where you can get good customer input? So I think if a manager says, okay, well, we're just not going to work on that project because nobody seems to care enough about it, I think that's a positive culture-enhancing action. Or you might make tracking charts of acceptance test results visible to the whole team, and this helps emphasize a shared focus on quality. That's one of the examples of the metrics that I had mentioned, and I think that's a good way to help people understand how we as a team or an organization are coming collectively toward meeting our objectives. Now, here's a couple of culture killers. I worked on a project once where I was actually on the third team that came in to work with this one customer to try to build the software system for him. The two previous teams really hadn't done a lot. I mean, they talked about requirements, but they didn't really write anything down. They didn't create a requirement specification. So we kind of had to start over. And our client was very frustrated by this whole process, our key customer. And when we explained that we would like to talk about requirements, he said, we haven't got time to write requirements, just build me a system. That became our mantra among the BA group for this project, build me a system. Now, eventually, so that's a culture killing kind of thing if you just say, okay, we'll go guess what you want and see how you like it. That's a pretty inefficient way to build products. But we actually were able to reshape things over time, and it's an interesting story that I don't have time to get into here. But we were able to steer it so that he did work with us on requirements. We wrote a really good set of requirements that turned into a really nice product people used for many years. And this guy was so happy with the result that after we had finished up our requirement specifications, he actually threw a lunch bash for the group of BAs who had worked on it. And I thought that was a pretty positive sign. Well, here's an idea. Let's include every requirement that anyone requests in your requirement set. It doesn't matter how much people will use it, how much it costs to implement, or whether it's even technically feasible. The customer is always right. No, the customer is not always right. I don't know why we say the customer is always right. They're not. We know that. Sometimes the customers are ill-informed or unreasonable or in a bad mood. I've certainly been guilty of those things when I've been a customer. I'm not always right. So I think it's a bad idea to take this kind of attitude. And here's another idea sometimes people want to try. Let's do peer reviews on our work, and then let's use those defect logs as input into the performance evaluations of the individuals who did the work. That shows you care about quality. No, that shows that you don't know how to manage people effectively. Very, very bad idea to use that kind of data for evaluating individuals. You should use it to evaluate your products and your processes, not the individuals. So watch out for culture builders and culture killers, and think about what aspects of your culture are either constructive or destructive. Now, I think that a commitment to effective requirements engineering is one of the signs of a healthy software engineering culture. My group had originally adopted 14 cultural principles, and the two shown here relate directly to requirements, and those are that customer involvement is the most critical factor in software quality. We're going to come back to this one in just a couple minutes. And the second one is this: our greatest challenge is sharing the vision of the final product with the customer. And here I'm talking about making sure that we have a shared expectation of where we're going to end up when we're done. So because we thought these things were important, we started way back in 1990 to systematically improve the way our group approached requirements development and management for our projects. And we thought that this gave us significant improvements in both the speed of our software development, the productivity, and in our ability to build solutions that actually met the needs of our customers. So these guided the practices that we adopted to help us engage customers more fully in our projects and to represent knowledge in a way that helped us reach the shared vision of the final product. So as we go along here, I'm going to tell you about some of the specific practices that can help you achieve these kinds of outcomes. Now, I've heard many people talk about management support. They might say, oh, interesting idea, but I can't do that unless I have management support. You've probably heard that too. And you know what? I don't care at all about management support. In fact, I find the word support to be one of the vaguest words that we use, and I try to avoid using it pretty much ever, even in daily life, because it is so vague and ambiguous. Now, too often, I think management support translates to permission. But you know, you don't need management support. You don't need permission to work the best way you know how. You're an adult. You're a professional. It's your job to do your work the best way you know how, as well as to always be looking for better ways to work. However, you absolutely do need management commitment to requirements processes if you want to ingrain those in the organization. This can't just be a bottom-up process where certain passionate individuals do certain things because they've learned that they're better ways. Instead, this has to be something that management drives. So let me give you some examples of what I think are signs of management commitment to implementing improved requirements processes. First, I think management should expect that the requirements for a project will be documented in an appropriate form. Now, there's a lot of debates over what those appropriate forms are, and there are a number of choices that you can select from, and teams ought to consciously decide what are the right ways for us to represent knowledge in our projects or from project to project. But management should expect that there will be some form of recorded knowledge about the expectations for the systems you're working on. Management should, as appropriate, work with the business analyst or others, who might fill this role, to provide the business requirements. Now, I have a special meaning by the term business requirements, which we'll get to on the next slide. Sometimes people interpret the term business requirements to mean any requirements from the business, and that's not what I mean. I'm talking about the kind of high-level objective sorts of information. So that has to come from someone who has the vision, and usually the person with the checkbook who's paying for the project. So management must be willing to work with the right people to provide that key guiding information. They should expect that the requirements that you do develop will be reviewed by appropriate stakeholders and agreed to. So we have to agree on those requirements before we implement each portion of the solution. Now, in a pure waterfall project, the portion of the solution is 100%. In a very highly incremental project, it might be 1% or 5% or 10%. But before you build each chunk of the solution, the stakeholders should agree on the requirements for that chunk. We should make sure that project plans include the necessary time and resources for all the requirements tasked. And I've seen project plans that didn't. And immediately what happens is the project goes off the rails in terms of schedule because time was not afforded in the plan for working on requirements, documenting the knowledge you acquire appropriately, reviewing that, and revising it. I mean, it's an iterative process. You have to expect there's going to be some revision going on. And this stuff just takes time. It's just the way it is. Management should expect that people will collaborate with other key stakeholders to gain their participation in requirements activities. Sometimes you need to get people involved in the process who are maybe not that interested or aware of how important their participation is. And so they need to have be able to work with their other key stakeholders at the, perhaps at the management level to gain their participation in the project as appropriate. We need to put into place appropriate mechanisms and policies to handle changes that inevitably take place on a project, and those have to be expeditious and effective. They should invest in training and tools and all the other resources that people need to learn how to do their job well. We can't just expect that, hey, anybody can be a business analyst, or you were a really good user, so why don't you be a BA next week? That's ridiculous. It requires a certain amount of knowledge and training and skills. We need to fund and staff the activities if you're trying to systematically improve your requirements processes. Sometimes people write process documentation to help explain, here's our prioritization process or whatever. That takes time. And while people are working on that, they're not working on project work, which means we have to recognize that management will make the time available for team members to spend on some of these requirements process improvement activities. It's not free, but it has a very high potential return on the investment that you make, because every future project you work on and the team works on can go faster and better than the previous project. So that's a good investment to make. So I think that a really important aspect of requirements is the business requirements, because those are the foundation of a successful project. It really has to make sure that all of the work we do after that, the rest of the requirements work we do and all the development work we do, has to align with achieving the project's business requirements. Now, one of the first problems I encounter whenever I'm talking with people about requirements is simply one of terminology. In some organizations, the phrase business requirements refers to any requirements that come from the business, including functionality and non-functional requirements and business rules and so forth. But that's not how I'm using the term here. And so I want to show you what I think business requirements are, and on the next slide I'll show you where they kind of fit into other kinds of requirements knowledge. So we might want to have some information about our business opportunity that we're trying to exploit or create or respond to. What are our business objectives? You know, we have lots of projects we could be working on, lots of projects the organization could be spending money on. Why are we working on this one? What are our business objectives? How will life be better if this project is done? And better can mean many things. That often boils down to money in some form. How are we going to tell if it was successful? What metrics might apply for that? I like to write a little vision statement. And in fact, all of this information I like to collect in a vision and scope document of some kind. Might go into a project charter or maybe a marketing requirements document if you're building a commercial product. But if you do go to the goodies page at processimpact.com, you'll be able to access a template for a vision and scope document. That's one of the deliverables that I have available. So I like to write a little vision statement that says kind of where are we going with this? And then we need to define business risks that we should be aware of, any assumptions that we're making or dependencies we might have on outside factors. What's the scope of our initial release? What's the scope of subsequent releases as we grow over time toward our ultimate vision for the product? What is the product not going to do? That is, what are some limitations and exclusions people need to agree upon and be aware of? And you might want to say something about your stakeholders and how they fit into the project. So I've got a lot of information about this in Chapter 5 of my Software Requirements 3rd edition book, and I think that really helps lay the foundation for a solid project. So let me show you how I think about requirements, plural, the different kinds of requirements knowledge. And this is my 3-level model. Some of you might have seen something like this before. The IIBA has something that's very similar to this, a little bit terminology difference, but I prefer my terminology, frankly. So I just gave you some ideas about what business requirements are and how they really set the stage and provide a guide for the rest of the work we do, perhaps collected in a vision and scope document. But that's not enough information for developers to know what to build. So we need to go down to user requirements. The IIBA calls these stakeholder requirements, but I'm not talking about stakeholder requirements. I am specifically talking about requirements the users have, things users need to be able to do with the product. That's what I mean by user requirements. And we want to collect those someplace. These are often represented in the form of use cases or user stories. We'll come back to that in a minute. But that's not enough information usually. And so really what we implement is not business requirements or user requirements, but we implement little bits of functionality. And so functional requirements, whether you choose to represent them as traditional functional requirement statements, or perhaps in the form of agile acceptance tests, fundamentally, those are the bits of information that describe the system's behavior under certain conditions. And traditionally, a software requirement specification of some type or a business requirements document is another common term. That's a place to collect this knowledge. So this is kind of the functional flow, but there's more to it than that. Sometimes you're describing requirements for a system that consists of multiple subsystems. Could be all software or maybe software and hardware subsystems. So you might have requirements for that system as a whole that then have to be broken down and allocated into specific subsystems. And then we have business rules, which are not requirements, but they're often the source of requirements or they influence requirements. Things like policies and regulations and so forth. We have quality attributes, often called the illities, which are another influencing factor. Sorry, I'm going to ignore that phone. I apologize for the ringing. We have external interfaces, which describe the connections between your system and the rest of the world. And then finally, we have constraints, design and implementation constraints that limit the choices available to the developer for some reason. So I like this model because it points out that there's lots of different kinds of information that we call the requirements. And the business requirements are really foundational for that. So make sure that you have, even if you don't like these definitions, some definitions that everybody agrees upon for what requirements are in your world. Now, looking at that second level, I like to take a user-centric approach instead of a feature-centric approach during elicitation. You can approach requirements elicitation, either by thinking about the features the product ought to have, like in a long bullet list, or usage-centric, where we focus on what users need to do. And I think in most cases that goes farther toward meeting user needs. And the two most commonly used techniques for usage-centric thinking are use cases and user stories. And the term scenarios is kind of related to both of those. So here's a formal definition of use cases. It's a description of a set of interaction sequences, that is a dialogue that takes place between one or more outside actors and a system, and the result is to provide some result that has clear value for some actor outside the system. Right? So that's kind of a formal definition. Now, user stories became popular with the rise of the Agile movement, and people continue to have great debates over how use cases and user stories are similar or different. Can you use use cases on an Agile project? If so, which comes first, the use cases or the user stories, blah, 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 blah. I'm really tired of those kinds of debates because I think there's a lot more similarities than differences between the two. And so here's a definition of user stories. It's a short, simple description of a feature told from the perspective of the person who desires some new capability, who's usually a user or a customer of the system. And the central commonality between these two is that we're focusing on the user and what they need to accomplish with the system instead of focusing on the features we're building in. That understanding of usage modes then drives our determination of what features to include, as well as priorities for what needs to be delivered first. So there's all this mystique that's grown up around use cases and another mystique around user stories, but at this high level, I think they look very much alike. And let me kind of show you how that works. A use case traditionally is named in this form: create an invoice. Okay, and that's something I might need to do when I do some work as a consultant. And so you always start a use case name with a verb. Everybody agrees on that. Create an invoice. Now, a corresponding phrasing for a user story is a little richer. It says, as a small business owner, which is good because now we know which kind of user we're talking about, I want to create an invoice. See, there's that kernel of the use case right in there. Now we want to explain why, so that I can bill a customer, and that helps give you a little bit of rationale, understanding why that requirement is important. So really, the user story phrasing in this format is a richer understanding than the simple name of the use case, but we're getting at the same objective. So the processes, though, do move slightly differently from these similar starting points. We start with the name of the use case. Then we have some conversations. The BA works with user representatives to understand how they imagine some dialogue taking place between a user and the system to perform this use case. And the BA might structure the information collected from that conversation according to a use case template, which leads ultimately both to a set of functional requirements after some analysis and a corresponding set of tests. Now, in a user story, the intent there is to have that serve as a placeholder for future conversations. So we begin by developing a set of user stories, and then we have some interactions with the appropriate user representatives to develop a more refined and more detailed set of user stories. Further conversations then might lead to a set of acceptance tests that, if passed, will demonstrate that the user story has been properly implemented. So those acceptance tests with the user stories really serve as a substitute for the more traditional functional requirements, but really they are two views of the same knowledge. Either one is fine. I mean, there's probably no real difference in the information content between the two. They're just written from different angles. But even better is to have both functional requirements and tests. And the reason I say that is because if you have two different if you have only one representation of that knowledge, just requirements, just tests, you have no choice but to believe it. But if you have two representations, functional requirements and the corresponding tests, then you can compare them. You can map them together and look for problems. And every time I've done that, I have found problems. And I'd like to find those earlier rather than later. So anyway, that's kind of the approach that I favor for taking a usage-centric strategy. And it provides a lot of benefits. We're using the user's terminology, not computerese, so this should be something users can understand. This is a great way to discover the functionality that users need to get their work done. It helps you avoid missing functionality that users actually do need to accomplish something. It also helps the analysts better understand the application domain because we're talking about the user's business operations. I don't know if you've ever worked on a project where you ended up building a bunch of functionality that no one ever used. I have. I hate that. It's just a waste. So focusing on usage rather than features helps you avoid building that unnecessary functionality. I can't stress too strongly the value of writing acceptance tests really early in the requirements process instead of waiting until the software is written. This helps you set the priorities for functional requirements as well, and now we have a way to trace our requirements back to the voice of the customer because we know where it came from and we know which customers provided that knowledge. So lesson 6 is that gets back to this idea of customer engagement is really a vital contributor to building high quality software. That was one of the cultural principles from my old group at Kodak. I believe it was true 27 years ago when my group first wrote it down, and I believe it's still true today. So let me show you how this works. Let's suppose that at the beginning of our project, we have some state here, but over time, as the project continues, what the customer needs evolves in some direction. It changes. And that what the developer builds evolves not always in the same direction. And if we don't manage this effectively, then at the end of the project, we have what I call an expectation gap, a gulf between what people needed and thought they were going to get and what's really delivered. And that comes as a surprise. And my experience has been that surprises in software are almost never good news. They're usually unhappy surprises. So what we want to do is try to find ways to avoid that. So let's think about customer engagement. And we want to start by understanding our stakeholders. Terms like customer, user, and stakeholder often get tossed around as though they were synonyms, but that's not how I think about it. If we think of this community of stakeholders, we can subdivide that into customers and other stakeholders. And customers could be actual users, either directly or indirectly, who maybe get the outputs from a system, or they could be other kinds of customers, maybe the people who provide requirements, or the people who pay for it, or the people who procure it for your company. But we're going to not pay attention to the ones in pink right now. We're going to kind of follow this user thread. And people often talk about the user for a software system as though all users belong to a monolithic group with similar characteristics and needs. But in reality, most products appeal to a diversity of users with different expectations and goals. So instead of just talking about the user in singular, spend some time identifying the multiple user classes and their roles and privileges for the product. So a user class is a subset of the product's users, which is a subset of the customers and a subset of the stakeholders. And you might find that not all of your user classes are equally important to you. And so we've got this community called favored user classes. Maybe you get a conflicting requirement request between somebody in one user class and somebody in another user class. Well, if one of those is favored, that is, their needs are more closely aligned with your business objectives you're aiming for, then that favored user class is going to have higher priority, meeting their needs, than some other group. Now, one thing I think is really helpful is to characterize the ways we're going to have customers involved in our project. So let's identify our stakeholders and their interests and priorities and build some kind of a little stakeholder catalog. Let's then go to that step I just described of identifying distinct user classes. But then you need to think about who is going to be the literal voice of the customer for each user class. And these are the people I called product champions. And that mechanism worked very, very well for us. When we implemented it, we used it for decades. I think it's also a good idea for the customers who are working with the IT people or BAs to understand their rights when it comes to requirements and also their responsibilities. Now, if you do happen to have a copy of the 3rd edition of my software requirements book, this information is on page 30. I've suggested 10 rights that customers have around requirements and 10 responsibilities. So you might go to page 30 of that book and then start with that and see if you can adapt it to work for your environment. You need to then choose appropriate elicitation techniques based on who your customers are and where they're located and how much time they have and so forth. Work with them to define acceptance criteria. How would they determine, yes, this is done, this is ready for prime time, I'll pay for it now, I will use it now. Finally, look for ways to engage your customers on an ongoing basis throughout the project, through prototype evaluations, reviews, and other kinds of activities. So let me show you how that might work then. So you remember that expectation gap that we saw earlier. Suppose that you could have a contact point with a customer before you've gone too far down the development path. And you can make corrections and get back on track. So what happens then is you adjust that growing gulf between the needs and the developer's work through maybe a prototype evaluation or a peer review or doing some acceptance testing on the work you've done so far. And if you do this a few times over the course of the project, this can greatly reduce the expectation gap and help your team come much closer to meeting customer expectations. So iterative and incremental development methods, such as agile development, were created in part to reduce that expectation gap, just like this, by providing many opportunities for adjustment along the way. We know the requirements are not going to be complete and perfect at the beginning of the project. We know we're going to think of new functionality. We're going to think of things we overlooked. We're going to have to make changes and adapt to evolving business realities throughout the project. So you need to use approaches that will let you interact with customers along the way to make sure the work your team does meets their needs at the end. So, not surprisingly, we need somebody to do a lot of work here, and there's much work that they might choose to do. The business analyst plays a central role in understanding and communicating a project's requirements. And I'm not going to walk through all of these, but they're all the kinds of things that BAs are used to doing, and it can be a lot of work. Now, it's important to note that someone always performs this role on a project, even if no one has a job title of business analyst. Sometimes those people are called requirements engineers or requirements analysts or systems analyst or a business systems analyst. And people have varying discussions about the differences between these. And, you know, it's really a matter of how you choose to define it for your organization. But someone has to do this work. Someone has to work with the project sponsor to understand their business objectives. Someone has to identify stakeholders and figure out who's going to be our product champions or other representatives. Someone has to perform elicitation activities and so on. So no matter who does it on a particular project, the person or the people who are functioning as business analysts have a lot of responsibilities. And it's important that you decide who in each project is going to have each of these responsibilities. It might be one person who's doing other things also, like development or project management. It might be a bunch of people who are splitting these tasks up among them on a large project. It doesn't really matter how you allocate it, but somebody has to do these things, make sure they get done. So I see the BA as performing a very essential bridging role. It's a communication role, bridging the gap between the user community and the development community, as well as facilitating communication of essential product information among many other stakeholders. So we might work with the project sponsor to understand the business requirements. Often they will work directly with user representatives to understand their user requirements, and then through their analysis and related skills to develop that into a set of functional requirements and non-functional requirements that get handed off to development. Now, this is maybe a traditional way of looking at it, and we might say, well, you know, in our Agile teams, our developers do that. That's fine if they have the skills, the knowledge, the personality, and the bandwidth to do it. So it doesn't matter who does these things, so long as they have all those things, the skills, the knowledge, the right personality type, and the time. Don't just give it to somebody because, well, you're a member of the team, therefore you can do all these things. That's silly. It's not true. We pass that same set of requirements information on to testing so that we can make sure that everything satisfies the expectations. Project manager is going to want to know something about how big is this project and how complex is it and what kind of dependencies does it have, et cetera, so they can make appropriate choices for plans and commitments and resource allocation. And you could have an arbitrarily large group of additional stakeholders, from 0 to a very large number of other people with expectations and constraints that have to be understood. Not necessarily all of them satisfied, but we have to understand them and to incorporate that into our plans and priorities. Now, there's an old story about the 6 blind men and the elephant. I won't reiterate the whole story here. I'm sure many of you have heard something like this. But basically, you have these 6 blind men who encounter an elephant, and they all touch a different part of the elephant and get their own impression about what an elephant is like. Well, they're all correct, but they're all incomplete. Each of them is giving you just one view of an aspect of the elephant. And I think the same idea applies to requirements. I have a chapter in my book called More About Software Requirements It's called The Six Blind Men and the Requirements. And what I learned a long time ago is that no single view of the requirements shows you everything you need to know. You know, early in my career, I was searching for the perfect picture. I want to draw the picture that gives me all the requirements knowledge that I need, or write the document that does that. And you can't. There's no one way to do that. So a skillful business analyst will thoughtfully choose appropriate ways to represent requirements knowledge that communicate all this information most effectively among the various stakeholders. And there's a lot of possible views. When we think of writing requirements, we think naturally of writing natural language requirements in whatever language you communicate in. And the natural language requirements certainly constitute the vast bulk of every requirements document I've ever seen. One of the services I provide as a consultant for 20 years is reviewing requirements documents. And they're pretty much all natural language. But I'm really delighted when I see a visual analysis model or two in there, some kind of picture, and we have lots of kinds of pictures people can draw to represent requirements from different points of view and at different levels of abstraction. Acceptance tests constitute a view. Prototypes and screen design, now we're starting to move into design and maybe implementation, but still it's another view of the requirements. Sometimes you don't want to just write a bunch of sentences that look alike. Maybe you want to put stuff in the table or some kind of structured list for efficiency and effectiveness of communication. If you have a lot of logic you're dealing with, let's look to techniques like decision tables and decision trees. So all of you who are doing business analysis should be collecting a rich toolkit of techniques that have all these things in there so that you can pull out the right hammer for every nail that you encounter. Data dictionary is a way to collect information about our data structures and elements. And we can take pictures. Sometimes you can use an audio clip or video clip to communicate more effectively than words. People have said for a long time, a picture is worth 1,000 words. They're actually wrong. Computer people know that a picture is actually worth 1,024 words. Okay, so it's a little bit better than that, but the idea is correct. And then we have this whole language called mathematics that we can use to communicate information in appropriate ways. So look for ways to communicate, not just ways to write natural language. All right, we're winding down here, so a couple more lessons to go. I think a guiding principle of requirements development is iterative iterative refinement of detail. Because the fact is, you cannot get all of the requirements the first time. And even if you could, you can't get all the requirements right the first time you try to collect them. So we have to recognize those truths, plus the fact that requirements will change. And instead of just assuming that we can just write them down once or have one conversation and one interview, one workshop with some users, we need to recognize the need for iteration. And so a more adaptive strategy that I like to do is to start with identifying these user requirements at a high level, whether user stories or use cases, and get just enough information about each of those so that you can do a first cut prioritization and think about what sequence might we implement these in. And then you can allocate those user requirements to specific planned releases or builds or iterations of your product. And then prior to actually implementing any one of those chunks, you can elaborate the requirements into an appropriate level of detail. And as change happens, you have to expect to go back and revise what you've already written, refine those into more detail, reprioritize, and reallocate perhaps to different releases or iterations as change happens. You just have to be adaptive here. So let's talk a little bit about terminology again and the various kinds of requirements work that you do. Some people call this whole discipline requirements engineering. Others call it all requirements management or just requirement stuff. But I call it all requirements engineering, maybe a little optimistic, but that's okay. And I split that into two major subdomains, requirements development, which is all the things you do to get good requirements, and requirements management, which is the care and feeding of those requirements from now to forever, till you no longer need the information. So we further subdivide requirements development into four kinds of activities. Elicitation involves discovering requirements, inventing them, and collecting them from various sources. We need to do some analysis to break those down into detail, to understand them better, to represent them in different ways, such as through models, to prioritize, and so forth. And as you do that, you find you've got some feedback loops here. You're going to have to go back and probably do some more elicitation because maybe you realize during analysis, gee, there's some question I forgot to ask, or there's a piece of information I thought I understood during the conversation, but now it turns out that I don't, or it conflicts with some other piece of information. So you have to loop back and clean that up. Specification involves documenting whatever we've learned in appropriate forms, and validation involves determining that the requirements are correct, of high quality, and will satisfy user needs. So again, we've got feedback loops here. And again, I apologize for the phone. I almost never get phone calls, so this is very strange. So you might have to go back and rewrite some requirements. You might have to go back and maybe reevaluate your analysis, or even do some additional elicitation. Now, this doesn't happen in a nice left-to-right linear fashion. It's an iterative process, and you just have to expect lots of these little loops to take place. So that's a key to success, is iteration here, refining the requirements progressively over time. Okay, last lesson here, and that's that addressing non-functional requirements contributes significantly to user satisfaction. Now, when people talk about requirements, they most commonly and most naturally think of the functionality a system is going to present to the user, but non-functional requirements are also very important, although they tend to be neglected by too many project teams. Now, some people don't like the term non-functional because it tells you what something isn't rather than what it is. And I understand the concern, but I'm not going to debate that here today. So I subdivide non-functional requirements into several categories. Now, if I think about constraints, for example, design and implementation constraints we have to respect, external interface requirements that connect things together. Performance is one of the non-functional requirements people often do explore and try to specify, and performance is a lot more than response time. It might have to do with throughput, how many transactions per second. My sister works as an IT person for a credit card processing company. They're pretty interested in throughput. Latency, how much impact do delays of time have on the performance of the system, especially for real-time systems, and efficiency of use of resources and so forth. But for the most part, when people are thinking about non-functional requirements, they're thinking about what I call quality attributes. And performance is really just another quality attribute. I just split that out because people do so often address that one as a separate thing. Quality attributes are often called quality factors or quality of service requirements, which I actually think is the best term, or VILITIES, because many but not all of them end in ILITY, like usability, installability, availability, but then we have others that don't end in ILITY, like robustness and security. And so people should take this very seriously, because I'm sure you've all used systems that did what they were supposed to do, but you didn't like to use them because they did not satisfy your quality expectations in some sense. So there are two views of product characteristics here. There's the external view of things that are important to users. And the users hold unstated expectations about these that go beyond the functionality. Things about usability and security and performance and availability and so forth. And if we don't discuss which of those are important to customers and use that information as design guidelines, then we're just going to be lucky if we end up with the quality characteristics that people want. Then we also have internal quality features that are aspects that are more important to developers and maintainers, things like modifiability, verifiability, portability, and so forth. And there are trade-offs between these things. We want to try to write them to be quantitative and verifiable and document those someplace, but there are trade-offs. Like if you make something super secure, then there's probably going to be a usability penalty because maybe people have to use two-factor authentication, which takes more time than just typing in your password once. So there are all these trade-offs, and we have to understand the expectations so that we can make good decisions about the trade-offs. So I've whizzed through a lot of stuff here, and just today only we have a special on lessons, and there's a bonus lesson, and that's that without high-quality requirements, software is like a box of chocolates. You never know what you're going to get. So thank you, and I will now pass the microphone back to Stefan Sturm from our IREB for some closing remarks.
Hi, again, this is Stefan. So there should be another slide. Can you advance one slide, please, for me? for the IREP slide? Yes, here we are. Yeah, Carl, always a pleasure to listen to your webinars, and it's very nice for IREP to sponsor these webinars because the topics fit very well into our education scheme. The CPRE is exactly addressing all these requirements-related topics Carl has been presenting to you during the last hour or so. We are not that much into business analysis, but we are very much into the underlying competencies when it comes to requirements engineering. And the certification is quite successful in 70 countries with over 30,000 certified now. And as Carl said, with the iterations, it fits very, very well into an agile development process as well. So check it out. Go to irep.org. Have a look at the handout. The handout is as well giving you information about the CPRE, but you will find everything on irep.org, free for download, and you might come back to me if you have any questions. So now I'm handing back to Carl, I believe, for the Q&A. Is that correct?
Yes. This is Chris. I'll be asking Carl a few questions. I just want to remind our audience, we do have from IREB a nice handout available for you. You might want to go to the handout section right now in the GoToWebinar panel and download that while we're doing the Q&A. So Carl, one question here. I'm going to probably going to paraphrase this one a bit. Let me find it. So they're asking, you mentioned the terms functional requirements, system requirements, technical requirements. What is the difference between these, or are they all used interchangeably?
Well, I actually didn't use the term technical requirements as far as I know. I don't think I said that, but it's something people do often talk about. And, you know, the problem with the terminology here is that people just simply, even after 60 or 70 years of writing software, don't agree on the terminology. I use the term system requirements to refer to requirements for a system that consists of multiple subsystems. In other words, what I'm calling a system there is not just any old random information system, but something like, say, if you go to the supermarket and just look at the workstation for the cashier, there's lots of pieces there, right? There's a scale integrated with a barcode scanner. There's probably a handheld barcode scanner when you have your 500-pound bag of dog food in the cart. You've got change dispenser, maybe you've got credit card readers, you got various displays, all sorts of stuff there, printers. And so that's a system because there's a lot of pieces that are working together. So when I talk about system requirements, I'm talking about the requirements for that product as a whole. Functional requirements are the individual statements that describe the behavior of the system under certain conditions. You know, there's some input or some stimulus and some condition, and the system does something in some way. And so functional requirements are going to be derived from all the other information you have about what users need to do and what the system has to be able to do and those sorts of things. You know, technical requirements, I don't even want to try to define that because that's just simply not a term I use. Sometimes people use that term to mean design. Sometimes they mean something more specific, but since it's not a term I don't use, it's not really a term that I should probably try to define here. But one thing I am going to do, I've gotten a couple of requests here I see in the questions for showing the website for the goodies. Okay, so I want to just pop that back up again. You see at the very bottom here, we've got the processimpact.com is my company website. There's a button there for goodies, or you can go directly to the goodies.shtml page. And if you want to buy the whole goodies collection, the discount code GOOD17 will give you $20 off. And yes, I know that not everything at that website is free at that page, but the profits from that all go to a disabled consultant who hasn't been able to work for almost 20 years because of a traumatic brain injury. So hopefully there's something there that you find interesting. So I'm sorry, another question, Chris?
Yes, great. Actually, this one, if Stefan is still with us, someone's asking how much the CPRE foundational level course costs. I don't know if there's a website to direct them to, if that's the better way to go, if you just like to answer it straight out.
This is quite difficult to answer because the prices for the courses are made by the training providers, and as you might imagine, there are plenty of training providers out there having totally different prices for the training, high price, low price. There are as well online trainings available. You will find them on the website as well. So I simply can't answer the pricing question.
Sure. Okay, moving on to another question, and if we do have well, we're almost at the top of the hour. Carl, someone's asking if you could tell them about BDD scenarios and if you use them in your practice.
No, actually I can't. Not something I can address.
Okay, very good. We are at the top of the hour, so I think we're going to just call it there. First, I'd like to thank everyone, including Carl and Stefan, but everyone for attending. It was a very informative presentation. Thanks again to IREB and the International Requirements Engineering Board for sponsoring today's events. I'd like to remind everyone that today's webinar, along with the slides, will be archived at ModernAnalyst.com within a few days. And this concludes today's event. Have a great day.
Thank you. Bye-bye.
Thanks a lot. Bye-bye.